I'm Kevin Price, and very happy to be with you here today. We're going to be talking about drones and ultra high resolution imagery, and I'm going to give you a couple of technical stuff, and Don's going to talk about some of the cool applications that he's been doing here in this region. So, just a little background. I'm an early retired professor from Kansas State University. I was in the Department of Agronomy. I also taught at the University of Kansas, and I was the Associate Director of the Kansas Applied Remote Sensing Program. Give you a little background, got a lot of publications, 40 million in research grants. The reason I tell you that is that we work with people in helping them write proposals. Got a lot of experience in winning. We just won a $15 million NASA grant, so we like to team up with our dealers and work with people to try to put together proposals. I was the advisor to the U.S. National Research Council on drone applications in agriculture and in environmental management or natural resource management, and also an advisor to NASA, to NOAA, and to the U.S. Secretary of State as a scientific advisor. So we bring to you some credentials that can help. We're going to get into the remote sensing part. That's where I cut my teeth, is in remote sensing. But we have a team that's highly skilled in the use of drones. Some people had caught this. Don hadn't even caught that. That is the dashboard of Kurt DeMuth, who's over here. He's our COO. We're located in our headquarters in Denver, Colorado. He is escorting the Predator drone back into the United States. You don't get to do that unless you know something about drones. Kirk, one day, he's a good farm kid boy from Kansas. He says, I've crashed over $1 million in drones in my career. You don't get to say that unless you're flying really expensive drones, all right? And when you're a test pilot, you're going to crash. They're going to crash. We work with helicopters. A lot of our work we're finding, though, and I will tell you that drones are all exciting and all that, but they're not cost effective for large areas in agriculture. You're going to spend a lot of time and money that can be actually done much cheaper if you put a Cessna through the job. And the imagery is almost as high quality. You can get about 2-inch resolution with the Cessna. We have literally mapped and counted the tomato plants with Cessna imagery in California. So there's nothing wrong with using a good old standby, and Don will show you some of the imagery from it. This is just another drone. All right, there's basically two types of drones. There's what we call fixed wing, and there's multi-rotor. And the fixed wing, basically like an airplane, one of the best designs that we find for the fixed wing is a delta wing, kind of a flying, it's like a B-2 bomber. They perform the best in wind. If you can't fly in wind, don't fly in Kansas, because it blows all the time, and there's a lot of other states that are like that. So you've got to have an aircraft that'll handle well. We've had this one with a tailwind up to 100 miles an hour. The wings were still on it when we got there. Turning it around and flying back into the wind was probably doing 2 miles an hour, but it's a pretty durable aircraft. And we're not here again to sell you drones, but we want you to make sure that when if you decide to buy one, you buy one that's going to do what you want to do. You can do about 1,000, maybe 1,500 acres a day if you're doing map quality drone work. You could do maybe 200 acres a day, and that would be a really hard day with what we call a multi-rotor. Multi-rotors are a lot easier to learn to fly. Problem is when a motor goes out, they come down like a ton of bricks. And I don't have time to ask this, but usually I've been in conferences where I have 800 people in the room. How many of you have flown a drone? And about 10% of the hands go up. I say, how many of you have crashed your drone? And the same 10% of the hands go up. I said, how many of you had to pick your drone up in a black garbage bag? And all the same hands go back up. So they crash, and you're going to crash, is what I should tell you that. If you've got a really expensive camera on there, you don't like crashing. Okay, a little bit on remote sensing. Remote sensing is sensing something without being in physical contact. So when you use a camera, you're remote sensing. But usually we think of remote sensing being more working in the color infrared region. When I say color infrared, I'm seeing natural color, which is what we see and the cameras collect, natural cameras collect, and the infrared. So you collect something that gets the blue, the green, and the red, and then the near-infrared wavelengths normally. What we're really sensing when we sense for plants is chlorophyll density. And the higher the density of chlorophyll, the higher an index I'm going to show you. How many of you are familiar with the NDVI? Most of you. Okay, it'll be quick then. This is a soybean plant. Part of the plant is healthy, part is sick. We're going to look at that plant in blue, green, red, and near-infrared wavelengths. And so you see it's dark in the blue because it's absorbing blue light for photosynthesis. It's brighter in the green because it reflects more green light. But notice the healthy part is darker than the thick part in the green. And notice in the red, again, we're absorbing energy for photosynthesis in the red wavelengths and reflecting more in the in the sicker part, we're reflecting more red light. Now, people say, well, it's the near-infrared that tells how healthy or sick a plant is. Here's the dead leaves on the table, and here's the healthy leaves. I can't tell much difference between them. It takes a combination of the bands, where you take this is the NDVI equation, near-infrared minus the red, or it can be a green or a blue band, a visible band. In other words, near-infrared minus a visible band, plus, divided by, there's the divide sign, near-infrared plus the visible band. And that is an NDVI. And what you're doing is as plants that are healthy are going to have lower visible light, they're going to absorb the visible light. And if they're healthy, they're going to reflect more in near-infrared. I don't have time to explain why, but just trust me. That this will be higher. If you've got healthy plants, the values in here in the plants will be higher, and the values over here will be lower. So the difference between them increases. And then you normalize it by taking the product of the two bands. So this is the natural color. This is soybean in the spring in Iowa. Natural color, color infrared, and an NDVI. So you kind of see the three different types of indices. And what we do quite often when we map the fields, we create a map like this for every square inch or two in the field of an NDVI map. All right, the last thing I'm going to talk about is cameras. There's a lot of cameras coming on the market, and there's a lot of things that you need to know before you invest thousands and thousands of dollars in some of these cameras. You need to know things like what's the sensor size and how many megapixels does each sensor in the camera collect. What's the signal to noise? Does it have a high or low signal to noise ratio? If you get a low signal to noise, you're just going to get a pretty picture. You're not going to be able to see the subtle differences between things that are important to you in the field. How wide is the lens? A real wide lens will create what's called vignetting, and you'll end up with a problem when you put the images together, and you'll have an image that has banding in it and stripes in it. I just looked at some today out of Australia with one of our dealers. He was flying another camera, or he had a person who flew it with his drone, and he had real bad banding problems. Band-to-band registration. When you have multiple lenses, you've got multiple detectors, and then somehow you have software that puts them all together, and it's usually quite difficult to get them to co-register nicely. And then when you have more bands, you have more data to process and more data to send through the line back and forth to be processed. So I used to teach the PhD students that hyperspectral was the answer. I don't teach that anymore now that I've gotten into drone image analysis. You would just overwhelm yourself in the data. And then when I do the analysis on the data, I don't find a great deal of dimensionality when I'm looking at plants. In fact, I just processed 5-band data recently. The computer told me when I ran principal components analysis that I only had 2 dimensions in the data. It means I have visible energy and near-infrared energy, and the rest of it is just redundant information. So you may just be collecting a lot of redundant information. Let me show you with the cameras that are coming out that I call multi-lens, and I'm going to remain generic here. Multi-lens, I've taken and put the sensor size that's in the camera on a quarter to give you an idea how big the sensors are. And then with the camera that we often use on our drones, we use the Canon SL1, and there's nothing sacred about that, but I just want to show you that the detector is much bigger that's in the camera. And when we're flying Cessna, we're using a full frame, 35 millimeter equivalent, and that's how big that sensor is. The bigger the sensor, the higher the signal to noise. The smaller the sensor, the lower the signal to noise, and that'll make sense in just a minute. Here I've got a summary chart. This stuff is all going to be on the web, so you can look at it in more detail. But here is multi-lens 1, 2, and 3. Notice that there's 5 bands, and 4 bands. When you look at all the bands combined, this is 6 megapixels, 6 megapixels, 4.8 megapixels. The Barbie doll camera, the pink one that some of the little girls like to buy, like 1995, actually has a higher resolution than some of the new cameras that are being sold at $5,500. So go buy a Barbie doll camera and get a couple of them, and you'll maybe have a better camera in some ways. Here's another multi-lens that's a little higher. The GoPro camera, higher. The Canon, this is a point and shoot. It's 36 megapixels. The one that I just showed you, we recommend is 53.8, and a full frame 6D or 5D is about 60 to 66 megapixels in size. Why is that important? The bigger the sensor, I'm showing this as a small sensor and this is a bigger sensor, the individual pixels, the more photons strike the surface and register energy. And so as the energy level increases, the strength of the signal increases, and the noise is overpowered by the strength of the signal, so you can detect things. You get a small one, you have smaller, fewer photons striking, and you get a lower signal-to-noise ratio. Now this is what that means when I say lower. There's high signal-to-noise, so you can see the word signal really well. Low signal-to-noise, you can't see it as well. High signal-to-noise, low signal-to-noise. So if you're trying to detect differences, you want a sensor that has a high signal-to-noise ratio. I'm not in the business of selling cameras, so I'm not trying to tell you one camera versus another. I make zero money from Canon. I'm just showing you that's the one that we've converted. Doesn't mean that's the best one. There's a lot of really good ones out there. But check it out. Okay. Finally, 5 bands. Notice that the blue band and the red band are very similar to one another. Here's the green band, it's a little different. Here's the red edge, and there's the near infrared. If I had to pick and didn't want to process a lot of data, I'd probably take this band and that band and not use the rest of them, just because it's a lot of redundant information. What am I getting in this one that I'm maybe not getting here, and vice versa? What am I getting here that I'm not getting there? If they look the same, because the data are the same. All right, Don, I'll turn it over to Don and
just push the right button?
yeah, just, yeah, yep.
Okay. All right, so while you digest all that information, my name is Don Cummins. I'm from Natchitoches, Louisiana. I don't have all of the pedigrees behind my name as Dr. Price does, and I'm not a public speaker either, so I'm just going to try to film some of the pictures, and you'll see that in just a minute. So, who are we? Like I say, I'm Don Cummins. That's my wife, my little boy, on a trip somewhere that I was actually taken a couple years ago. He's 3 now. That's the airplane that we do most of the data collection with. There's one of those drones that he was talking about, and about 30 minutes later, that drone broke into about 5 pieces because pilot error. I run it till the battery quit, and it quit flying and it crashed. So it does happen even to the best of us. And
Hot glue sometimes will salvage it, right?
It hot glue, and we were flying the next day. So I've used black tape in the field before, take it back up, and send it back up in the air. They're pretty durable. So we are from Natchitoches, Louisiana. For those of you who don't know where it is, it's kind of central south. These lines show the blue line or circle is where we can get in about an hour. The red line is about 2 hours. So the reason that's important is because our focus is getting to you on time and quickly. So we can be pretty much anywhere within that red radius in a couple hours from the time you call. Provided the weather's good, it's good flying weather, we can get there pretty quick. What do? So basically, if you call us, the first thing that we'll do is I'll ask you a question. What are you looking to get out of this aero imagery? To back up just a little bit, I'm a dealer for AgPixel. I collect images, they process, and we work together. I use their expertise to put together good, accurate maps and images that Dr. Price just talked about. My part of it is I deal directly with the end user, the consumers. I'm the guy that answers the phone when you call. I'm the guy that flies your field, takes the pictures. When you process it, I still talk to you, and we work through the imagery and try to help you use it any way that is beneficial to you. So when you call me, probably the first question I'll ask you is, what do you want to get out of this imagery? I want to sell a bunch of imagery, I want to fly a bunch of acres, but if it doesn't benefit you, I won't get your call again for the second round. So I want to know what you want to do with it before we ever get in the air. After that, we're going to draw a boundary around your field, and then I'll take off and I'll head over there. We'll grid your field. You can see the little airplane flying. That's the actual field I flew about a month ago. We just fly flight lines back and forth. We take overlapping photos, and we merge all those photos together into one giant map, which will have the same resolution as each individual photo. So after we take all the photos, we land, I upload them to AgPixel. They start the processing sequence. Over here, this is just a list that I screenshotted off of our processing page. This is the time to delivery: 4 hours, 5 hours, 4 hours. Up here is 23 hours. So that's typical. Once I land and upload the photos, they're usually ready for you to view in the map within 24 hours. And that's important for most applications in farming, so that y'all can start doing something like that. After that, they get delivered to this portal. You'll have access to this. You can view the maps online. You can download them to any GIS application that you use. SMS, Agfinity, excuse me. They can go into mobile applications, QGIS, ArcGIS, pretty much any kind of GIS program this imagery can go into and can be utilized.
They're geospatially related, so that when you pull them in, it'll pull in the shapefile information and it'll be georeferenced.
Right. So these little arrows here are your download buttons, so any of these maps that you pull up, you can just download them straight to your computer. We offer several different vegetation indexes. Typically the blue NDVI, green NDVI is kind of the go-to, but we also offer ortho, which is a color infrared. We can shoot in RGB, which is natural color, so just like a normal camera would shoot. All just depending on what you're needing. So, excuse me. I was blessed with the flu about Christmas time, and it's still taking cough drops by the pound, so it's trying to keep from gagging on you. But I'm healthy now. I just have a this is kind of a 2017 in review. These are the states that we operated in last year. We mapped about 1.2 million acres in 6 states. Put about 300 hours on that cardinal. Here we're going to get into some of the imagery that we started taking. I started this slide because it's kind of ground level. The customer sent their soil sample data. We started with those points. We use SMS a lot. It is a good platform to incorporate all this data together. So those are your pH, calcium, phosphorus maps from the soil sample data. This is the color infrared that we shot of some rice, and this was, I think it was maybe 2 or 3 weeks old. It was very young. You see a lot of bare earth. We shot it at about 1,000 feet with a Cessna. I think it was around 2-inch resolution. So they wanted to see how early we can get over that field and start collecting imagery of the rice. This is the NDVI map of that field. The red is going to be your bare soil, and then the green is going to be your rice. So we shot this field several times throughout the year and wanted to see if those really early images corresponded to later images and eventually the yield maps. So after the imagery, we combined all of the soil data, the imagery data, and we actually built a prescription for the aircraft to fly on a variable rate of nitrogen, and that is the actual prescription that we flew. Each of those grids, I believe those were 80 feet wide and 150 feet long, and you can see the 3 different rates that we used for that particular field. This is just another example of cotton applying a variable rate PGR. That was a color infrared, the NDVI. And you can see a lot of variability in this field. They had a lot of plant height difference, so they wanted to do a variable rate application of PIX. Here was a prescription map. Again, an aircraft applied this. This was an air repair variable rate gate that was used in this field. We applied 4 rates, 1, 3, and 6 gallon, then a 0 rate around the edges and stuff, and through some ditches. This is two separate aircraft systems that we've worked with, the Vondran gates, which are up in Arkansas is where they're manufactured, in area in Cleveland. We can provide prescriptions for either one of those gates that we're working those aircraft. We've worked with 4 separate aero applicators this year who have successfully applied variable rate applications from our prescriptions. This is was kind of an interesting set of fields that we worked on with a farmer. We flew a lot for him this year, and he was trying to collect as much data in this area from soil data. He mapped it with a Varus rig, and then had some researchers doing some work on his cotton. So we collected a lot of data in it. This is still an ongoing project, trying to analyze everything that we collected from it. But there's a color infrared. The field in the middle is what we're focusing on, and that was all cotton. Soil CECs, soil organic matter, and then the harvest data, which is streaked up a little bit. They had some issues, but we are able to put it all together, get it delivered quickly so that he can be looking at it. Hopefully, as soon as he gets his harvest data in, he'll have all the data together where he can start making decisions for next year. This was another early rice field that we flew in Mississippi. The producer called and he said, I need you to show me where we have some weeds growing up in our rice. So we went over there and flew the field. Here's the NDVI map. And here's a zoom in of some of the weeds. And you notice they go vertical, the rice is planted this way, and I asked him what was up with that. And he said that year prior they planted soybeans the opposite direction, and that's where the weeds actually originated from. So that's why they went in vertical rows. So after we collected the imagery, we went a step further and we did a classification on it to try to pull out the weeds and make them more visible. And this is what we returned. The blue is water, pink is weeds, and green is rice. And I sent it to him, and he said he wanted to, do a variable rate spray on the weeds and just knock them out. I just found out yesterday talking to him that he actually set me up because he'd already sprayed the weeds. He knew where they were, and he just wanted to see if we could find them. And so I said, well, how did we do? And he said, you're spot on. So it made me feel good. Chemical drift on sugar cane. This is in South Louisiana. This was partially an insurance claim or just want to document where the extent of the chemical drift on the soybeans. So several fields were involved. You can start to see up in the center north, a little field kind of down that west side. You can see where the wind blew the chemical into the sugar cane. It's really obvious from these maps. So we zoomed in and boxed out some areas where there was some chemical drift. Makes it so much easier to go to each party and have a fair estimate on how much was affected, where did it come from. Obviously it came from the north.
And notice that it doesn't show up really well in the color infrared, but once you compute the NDVI, it's picking it up a lot better.
Right. So Kevin commented this morning on how good the imagery worked or looked, and it was kind of funny because this field, we were battling clouds, and everybody knows in this area we have clouds almost every day. You can't fly good color infrared imagery with partial cloud shadows because the clouds actually return a greener NDVI reflectance than it should be. So if you have any kind of cloud cover, it messes with your map. This day I had a beautiful clear day. I flew down there, and when I got approximately 2 miles from the fields, there's clouds everywhere, and there's about 50% cloud cover. The advantage to flying a small airplane is you can circle the field, wait for the clouds to pass, jump in there, get some good imagery, and still collect data even on a day when you have a lot of clouds. So it took me about 3 times as long to collect imagery on this field as it should have, but we got good cloud-free imagery on the whole thing. And that happens a lot. I don't like to do it that way, but sometimes it's our only choice. So one way or another, we'll get the data collected for you. A lot of people ask about satellite imagery. Satellite has its place. It's low cost. It's delivered usually 2, 3, 4 times a month, depending on when the satellites pass. We have no control over that.
And cloud cover conditions.
Cloud cover, if there's clouds it's hidden, so nothing we can do about that. But it is a low-cost imagery. It can be used more regular than a manned aircraft. So here's a comparison. April 24th was a satellite imagery. April 27th, I flew it with the Cessna. So you can see the similarities. You can see a whole lot more detail in the manned aircraft. So maybe the satellite's a way to see if you got any issues you want to go look at closer. Then you can send a plane in and possibly save some costs over flying so much area with the aircraft, or you might hone in on some areas you didn't know you had a problem with. We offer the satellite imagery through the same portal delivery system as the manned aircraft. So everything is the same. It's easy to access. It's all right there together. You don't have to access two different systems to get that satellite imagery. And it's all processed through the same company, so it looks similar. And there's no extra processing you have to do to try to make it work together in something that you can use and look at together. I don't know how we are on time.
I don't either. Where are we?
2 o'clock.
Getting quit at 2?
No, what time is it?
We
I forgot what time I have to quit.
15.
15? Oh, we're in good shape. You're almost finished.
This is just a couple of uses for the imagery that we did this year. This is not necessarily ag-related, but I'm sure everybody was affected in some way from the hurricanes this year. So this was Port Arthur. We flew about 100,000 acres in Port Arthur right after Harvey hit land the second time. Mapped some flooded areas. There's a shot out the window. And we actually went on the ground as well. Took a boat down there, and it's a funny picture in an unfunny situation. But that's kind of the way it works sometimes. Our plans are not exactly how we expected it, but I'm sure that's a very nice place. You can buy it if you want. Waterways, we mapped this is an area on the Red River. Invasive species was a giant sylvania, documenting the growth of it. The first survey was done March 8th, the second April 19th. I think it was 42 days later. You can see the green is outlining the actual sylvania that we were looking for. 40 days later, it had grown like 700% in size, so that stuff grows really fast. And it's been a good use for this kind of technology as well. The data behind those images, everything that we collect is actually data driven, so we can go back and work through that data and collect the information that's needed. Basically, that's it. I'll be happy to answer any questions, anything you'd like to know more about. And we've got cards and pamphlets on the back. So feel free to pick them up.
What camera are you using to collect the data?
So the color infrared was all collected with Canon 6D that he mentioned earlier. It's full frame sensor camera. It's a modified DSLR Canon camera. All the RGB imagery, most of it was collected with Canon SL1.
Okay. So what software are you using for collecting the data?
We collected with software that AgPixel actually
We have
created.
a guidance system that tells them right where to fly, what time to fly, all kinds of things. You can tell them more about it than I can.
Right, sure. So you put in the field boundaries into the guidance system. You take off, you head to the field. It calculates the flight line width that you need for the proper overlap. So we can set it up for 80% overlap, which is typical. On RGB stuff, we can widen that out a little bit. As you change altitude to adjust for the resolution, the lower you fly, the higher the resolution you'll get. Your flight line is going to narrow up, so it automatically calculates those flight lines, so you always have it perfect. As long as I flew my lines straight and stayed on the line, I've never had an issue with processing. If there ever is an issue, it's because I fell asleep or something and got off my line. So it works really well.
Can your software accept data from a Duncan Tech 4100?
I don't think it's not. That's a question we have to ask our technical people. It's designed for the cameras that we normally recommend to our dealers.
Why I asked what he was
Yeah,
working with.
yeah.
That's a type of sensor?
It's a 35mm.
Okay.
Yeah, I have a Duncan Tech. I had a Duncan Tech for quite some time. I bought one of their first ones back a long time ago. It's a video camera with a frame grabber. Yeah.
It is typical when you fly the UAV under the cloud, you have sometimes you got images, some part is dark, sometimes it's black, because the shadow. How can you fix that?
Yes, sir. Can't fix it.
You can fix it?
Yeah, so that's why I had to fly that particular field several times, and then I pulled out all the cloud channel images.
So you
And
just,
even if
just
it's
threw
just
it
a
away,
portion of it.
you mean?
Right.
Now we've flown in tropical rainstorms coming into Florida under the clouds and got some beautiful data,
That's something.
Okay.
which
As long as
surprises
even-
people.
Even lighting, it works.
Yeah, it's like, you know, you go into a place to have a portrait taken and they shine lights through diffusers.
You know, sometimes we fly, we flew it, the UAV, the UAV chase the cloud or cloud chase the UAV, you know. It's really hard sometimes, so,
Yeah.
uh,
Just like they know.
What does the clouds have?
yeah.
But influence,
Yeah,
yeah, it'll change your brightness values. If you're trying to,
but aren't you using a ratio, so?
yeah, that's what I was just
I
gonna
mean,
say,
the
is that
infrared is
you
gonna-
could, the ratios will help normalize a lot of that. Sometimes when we're really concerned about it, when we're flying drones, where we're flying lower, we put calibration panels out and then use that to adjust the imagery.
Well, it's the white fluffy clouds that come in.
Yes.
Half of your field
We-
is sunshine and the other half.
We call them popcorn clouds.
Yeah, yeah.
It's the popcorn clouds that, I was teaching a group from the Middle East one time. I held up a satellite image with all these popcorn clouds on it. I said, who can tell me what this is? And in unison, all 50 of them yelled sheep. So I realized I hadn't taught them the scale at which we were looking at. They were clouds, but they thought it was herds
But
of
if
sheep.
you're looking at vegetative indices, does that really matter, is my question.
No, not, well,
I mean,
what really matters is whether or not, if you need scientific quality data where you know how many watts per square meter per radian per second per wavelength is coming out of there, then you shouldn't be using these cameras in the first place.
Yeah.
But if you're just wanting to look at relative variation within the field, then you're right, it won't matter because it'll all be relative.
Right.
What about ground truthing? You wrote prescription for PICS, and you use an NDVI. How are you ground truthing this to know that you're writing the right prescription?
Yes, sir, I'm glad you asked that. Because we don't recommend writing prescriptions solely off of NDVI imagery. All of those prescriptions that were written, we send the imagery to the farmer or the agronomist or whoever's making the decisions. He compares it to his ground truthing, his soil data, his knowledge of the field, and then he tells us to adjust those zones. So we'll create like a 3-zone map from that NDVI, and he'll tell us how to adjust those and what rates to apply to each zone. So we are just delivering the raw data and then take his recommendations to create the prescription.
So you're not actually going out to the green seeker collecting and trying to collate that back to it?
I don't.
We've done that to see how well they correlate. Got 0.93 on the R squared on it for corn with green seeker. But the NDVI, I like to use the analogy that the NDVI is like a thermometer. Doctor sticks a thermometer in your mouth and says, oh, you've got a fever. Then he doesn't make the prescription based on the fever. He makes a prescription based on follow-up tests, and that's your field work. You let the agronomist be the doctor, and the imagery is simply the thermometer that tells you where you've got problems, and then send a doctor out to the field to make the prescription.
We'll be talking session after next here as well and getting more details on that. Because I'm be talking with a producer who uses this for prescription maps. He's gonna talk a lot more detail about how they did the ground truthing and stuff.
Now, one thing I'll add to that, I don't know of any doctors that are throwing their thermometers away. They're
I think
valuable.
the images are great.
Yeah.
I mean, the images are excellent. But if you don't walk that field, you don't know what's out there.
That's right. You've got to relate it to the ground. You're spot on. There's a lot of people out there saying you don't need to, and we say they're wrong.
Which growth stage of imagery have you seen matches yield maps and things? Like on, say, cotton, is it bloom, pre-bloom?
So in 2016, we flew a cotton field 3 times from June through end of July. And all of them correlated to the yield map. The difference was as there was more coalescence of the leaves, those low areas and stuff filled in. So there's a lot more red on the first imagery that was flown. I want to say it was early June. It may have been mid-June. But they all related closely, but I would say the early to mid-July images were the closest, which also benefited the PICS application.
I was
So,
gonna say, we've done some pigs and it'll even out,
right.
you know, the image will. So I don't know if you could still correlate an image to a yield map.
Yeah, so, my recommendation is early July, early to mid-July before you do a fixed application. That way you can use it for that as well. And, we can, if you want to get with me later, I can show you some comparisons, to the yield maps as well. Some of them are really close, some of them that weren't. The farmers explain why, you know, it might have been some other kind of issue, but, most of them have been pretty close.
What's the cost per acre? Depending on how far you're having to go to get it, but
Typically, you know, that's kind of my general area what was within those rings, so, I'm gonna start about $2 an acre. I have a minimum acres because I can't fly to, you know, Memphis and do 50 acres. But, if you look at about $2, if you're flying, 3,000 acres or more, $1 an acre. So as the economy of scale go up, I can drop my price. So my goal is to get it $1 an acre. It seems to be something that everybody can choke down a little easier. So that's where my goal is to be, just have to have enough acres to justify it. The satellite imagery, looking at maybe 10 cents an acre per image. So if you get 3 images a month, 30 cents an acre, something like that.
So if you have a clear day, how many acres can you cover?
Our biggest day we did about 75,000 acres. So that was cloud free, didn't have to fight the clouds at all. It was beautiful weather. That was 6-inch resolution imagery. So I mean, if I go up to 12-inch resolution imagery, I can triple that. So it depends on the resolution you need.
What altitude you flying to get that?
6 inches, 3,500 feet, and then 12 inches is going to be up around 6,500 feet.
We have gone out and tested to see how many acres we could fly with the Cessna, 250,000 in a day. That was on a perfect condition situation. But you never get that kind of orders. It's usually 250 acres here, 300 there, and so on.
Right.
But put that into drone perspective. Farmer's not going to manage the field at 1-inch resolution anyway. So if you fly it and resample it or fly it at 10-inch resolution, they've still got more detail than they usually ever need. And you can save them a lot of money by being able to fly it more quickly. People say, well, and again, we fly the drones, so I'm not poo-pooing drones, but I'm just wanting to make sure you understand that that the cost effectiveness of a drone is, I use them all the time for research. We do really high level research where I'm flying 1/4-inch resolution on fields, and I'm literally looking at the inclination angle, the leaves on the genetic varieties that we're looking at. And the drone is perfect for that. But if I'm going to fly like Don is, where you're flying thousands or hundreds of acres, I can't make it with the drone. I've got to get in my truck and I've got to drive maybe 50 miles, part of it on dirt road, get out there, put it up. I'm going to fly it for 45 minutes to an hour. Don can be out there in no time with his plane compared to how long it takes to drive there and so on too.
As a comparison, early 2016, I was asked to do an early rice flight with a drone, and I went up there and spent 2 days flying 850 acres and had some cloud issues. It was hot, it was miserable, and 2 months later they asked me to fly it again. I was in the area. I flew it with the Cessna in 15 minutes. It was 3,500 feet, it was cool. I was like, it's not even fair.
So if you've got to have a drone and you want to get the drone stuff out of your blood, get one. But if you're going to try to make a livelihood doing this, you're in for a real tough haul. And some don't want to hear that, but it's a reality. We've been there and done that, okay?
My heart beats faster launching that drone than it does taking on an airplane. They're gonna come back to me.
I've seen other groups that have bought $50,000 drones and blown it to all the pieces on launch, for launch. Flew it right into a tree and you ripped it all to pieces. So. All right, thank you guys.